Hello, today we look at human factors in design, and as you will see through this class, this is a very integral part of the design process. It doesn't matter what kind of a product you're designing or what kind of experience you're trying to enable for the user. Many places you will find that the human factor is a very important aspect of the design process. So let's begin with looking at this idea of why bother about human factors in design, right? So this is a very crucial question that we have to answer for ourselves, because everything else that we discuss will depend on it. The main answer for it is the fact that most of the time we are designing some product with the expectation that a set of people, and ideally if it's a product that you're trying to sell commercially, you want a very large set of people to use it, right? So therefore your ability to make that product successful depends on how good the people feel about that user experience, and how good they feel about the user experience depends very closely on how well you have designed it for their comfort and ease of use. So for example, I mean, we have to always keep this in mind that if you were, supposing the world had evolved differently and actually dinosaurs had still lived, and dinosaurs had become the most intelligent creatures in the world, and let's say humans never arrived on the planet, uh, naturally everything else would have been designed differently. Imagine designing a house for a dinosaur, right? Imagine designing a vehicle for a dinosaur. So I don't know to what degree you watch science fiction movies, but generally in all science fiction movies they assume that intelligent life anywhere in the universe is all similar to us in terms of having two hands and two legs, and by and large, and a creature that is relatively erect has a face right on top, and so they always assume that. So anywhere you see any different, even though they may show you a different spaceship and different kinds of seemingly different kinds of controls, at the end of the day it will all be set up such that with two hands you can reach various things. There will be some kind of a chair you're sitting on. Maybe the chair is a little rounded, maybe it's straight, whatever it is. At the end of the day, there's a chair that you sit on which seems comfortable even for a human being. The size of the chair is also roughly the same. You don't see large chairs, small chairs, nothing. It all seems roughly the same, right? So the assumption is that everything everywhere has been designed for that kind of a creature, and on earth of course that is us. But if you really step back and ask yourself this question, supposing some other creature had evolved and things had to be designed by that creature for itself, right? So naturally the whole process would have been different. So just to give you an example, supposing it had been a octopus that had become a very intelligent creature and had become the most intelligent creature on the planet, and had created everything for itself, then what would its seat be like? Would you just have a bathtub? You would just have an octopus there when it has various arms, 8 different arms out there in different directions. What would you have as a seat? You're not going to have a seat of this nature for it to sit on, right? So would you have a bathtub here instead of a some kind of a bathtub on which it is sitting, and then you have controls all over this place. Some control this hand is handling, there's some control that handle is handling, this is something that is being switched on, means something that it can hold on to, a bunch of switches here, so things like this, right? So naturally you have to understand that when you design something, there is a user, and therefore the design has to fit that user. And at least maybe an octopus seems a very far-fetched imagination from our reality, but I wanted to point that out for you to understand that if the creature was different, you would design it differently. You won't just design something standard and put it out for that, right? So the same thing is true if you're talking of human beings. Human beings have a certain approach to things. You have to design for that, not design independent of that. Okay, so maybe more than an octopus, the creature that comes closer to us in terms of our interactions is a dog. So if you were designing something for a dog in terms of how it would sit, how it would lie down, where it would eat, things like that. Or if it were disabled, so we have people, when human beings are disabled, you have a walking stick, right? But when dogs are disabled, you have I don't know if you have seen these images, but you can see a dog, and it's unable to have its let's say rear legs are not there. So what do? They just have a set of wheels, a set of wheels that are attached to the rear side of the dog. Okay, and dog or mouse, this probably looks more like a mouse, but nevertheless, so you attach a set of wheels to the back side of that dog, and it is able to move. So it is able to move very well, right? So so any creature which has 4 legs, if it has lost 2 legs, you can set a set of wheels. So naturally, the design for that is different from the design that you would make for a human being, right? So this is the idea that you have to keep in mind. Engineers and most of us who are designing products for people are engineers, and typically they are logical. Okay, so there is some sense of logic in why they make something. Okay, but the problem is that people are not necessarily logical, or at least the behavior of people is not necessarily logical, at least from the frame of reference that the engineer is looking at it from, right? The engineer may have some idea of how a person should behave, but a human being is not really behaving like that. What we have to understand is that we have to design for the way that people are, okay, and not the way that we wish that they will be. Okay, so we have to design keeping in mind that today people behave in a certain way. Today people behave in a certain way, they dress in a certain way, they like doing things in a certain way, they have this level of patience. So there is a set of there's a framework of things that we associate with a human being as the person exists today. So we have to design for that framework, not simply say that, as per my logic, this has to happen first, then that has to happen, then the other thing has to happen, so I will design it in this linear fashion. The human being may not deal with the same set of events in the same linear fashion as a user, because he is a user, he or she is a user, they are not the person who created the product, right? So maybe by human experience we tend to pay more attention to the third item in that list rather than to the first 2 items. So we have to now work with the third item. As an engineer, as a designer, you have to work with the third item such that you accomplish all the things that you want accomplished, while still ensuring that the human being doesn't have to do something that's very unnatural. So a classic example where this comes into prominence in the form of a conflict is the current trend towards auto driving cars, right? So you read a lot in the news about auto driving cars, auto driven cars, and so on, and people are working on it. Big major firms are working, almost all major automotive firms internationally are working on some version of an auto drive car, right? So and the idea is what? The idea is great. The idea is that you always find yourself a little tired when you travel long distances and so on if you're continuously driving. So the idea is that the car takes care of the driving. You just sit back and relax like you would sit in a train, and the car just travels smoothly and just takes you to the destination. We already have good map related software which tells you where to turn left, where to turn right, etc. You just give it knows your starting point, it knows your destination, and then it plots a path to the destination. So that is already done. So the car has to take care of traffic and keep traveling, right? So auto drive car has been done that way. So what is the human aspect there, and how have the engineers dealt with it? So what is going to happen when you are sitting in this auto drive car? By and large, the car is going to drive. There's no problem, right? The engine switches on, and maybe you switch it on, and after that it will control the accelerator and brake and keep moving. It will just keep track of all the neighboring vehicles and so on, and just keep going. Now for any number of reasons, something may go wrong. So what is the engineer doing? The engineer says logically, and it's very logical, that as long as things are going fine, let the car do everything. So you don't have to do all mundane things, you don't have to do, you sit back, relax. When something goes wrong, the person in the car should intervene and make sure that it doesn't become very bad, right? So you basically don't want an accident of some nature. So suddenly a dog darts across abruptly, some dog or some small creature darts across, maybe you want to hit the brakes. Okay, so suddenly, or you suddenly see that in front of you something has happened, it's very close, so you want to abruptly hit the brakes. So you want to do something like that. So there are various instances where there's a sudden response that is required, or you see something far away that alerts you, that which the car has not been noticing. So something at a distance you see, I don't know, maybe there is some fire further down on the road, and you just want to be cautious, you want to pull over and stop. So you pull over and stop. So the engineer's approach is very logical. In an auto drive car, they say, by and large, the car will do all the mundane things. You sit back and relax. If there is some emergency, you intervene and you stop the car, right? Or stop the car or take over. I mean, you decide what you want to do in that emergency if there is something that you wish to do. So this is a very logical thing. So it clicks this first idea that engineers are logical. But look at the human experience. The human experience is very different, right? As a user, it is very unnatural to ask ourselves that, you just completely relax, you take your mind off of it, and then abruptly when there is an emergency, all of your attention will come right back and you will start deciding correctly. It doesn't work that way. See, normally when you drive the car, your mind is tuned to the road. You're watching the road. There's a road ahead of you. You're watching. Maybe nothing is happening, but you're still watching the road. You're watching the road. Your legs are the right place to hit the brake or hit the accelerator. Your hands are on the steering wheel. You've got the right position, and then you're watching. So and your body and mind are set to the fact that you may have to hit the brake, you may have to accelerate, you may have to slow down. All this is already there in your system. So you may even be conversing with the person sitting next to you, but your primary task is that car, that you're driving that car, and so you're all set for doing that. And so when something happens, even peripheral vision, something catches your eye, instinctively your body responds, and you start hitting the brakes, or you start accelerating, doing something, bunch of things you do. So this happens, even though it is tiring you, this happens well because you're already in that mode. You're in that mode, and you're already there, and your mind is set. And that is how you even pick up speed, right? You start off slow, you understand the traffic around you, and gradually you pick up speed. This is how you normally drive. So it's a process. The driving is a process. It is not an instantaneous event. So you cannot be, turned that side, sleeping and relaxing and talking, and then suddenly get into the right mode and hit the brakes and do all sorts of things. Your system is not tuned to it. So it's a very unnatural thing for you to do. Very likely you will not do it right. So asking a person to actually not be involved in a task for all of the time, but abruptly get involved in the task and do it right at that instant is a very unnatural thing, right? Abruptly in an emergency, you're asking this person to within a fraction of a second get into that mode, get everything right, hit everything right, position himself or herself correctly, hit all the buttons correctly, decide everything correctly. It doesn't work. So there will be a phase lag. The person has to first realize that there's something going on, then reorient himself or herself and get into position, do various things, and then by the time it is too late. So even though it seems very logical, expecting a person to be disconnected from the task and then abruptly get 100% connected to the task is actually very unnatural. So the logical part of the engineer fails to address the way that people are, even though seemingly it all seems right. Okay, so we have to, there may not be a good and easy answer for this situation, right? So you may have to work more. So the point is, you have to first realize that this is an issue. So even though it seems very logical, it's not going to really work on the road. So you have to first realize this and then find a way to handle the situation. So this is the point that we wish to make. So we also have to understand human needs. So like that's what we saw right now in this auto drive circumstances, capabilities, behavior. It's very important to understand our behavior and then design to accommodate all of this. We don't design to expect some unusual behavior from the person. We expect the normal behavior from the person, designed to get the product to work well with the normal behavior of the person, whatever is the existing behavior of the person. So I will give you an example of how we handle behavior in just a moment. We have to also address cultural aspects. So something may be true in India, maybe the same thing is not true in the United States or in Europe or in different places in Europe or Australia, right? So that also we have to keep in mind. So I am going to give you an example of both of these. So here is the dashboard of a car. Okay, so this is the dashboard of a car, and increasingly you will find that this region, many car companies try to keep it very curved. They don't keep it flat, they keep it very curved. Okay, so why do they do that? I mean, maybe not every car company does it, but several car companies seem to do that. Why do they do that? The idea is that there are aspects associated with the vehicle which are associated with safety. Okay, so they don't want you to keep any object here, some object here, some other object there, etc., which may hit you in the event of a accident of some nature. So you will notice here there is some sign here which usually means that there is a airbag there. So that airbag will open, right? So the idea is that when there is some impact, the airbag opens and the person should hit the airbag. They will move forward because their car is coming to a halt abruptly. They will move forward. Their seat belt is trying to hold them back. Their face is still moving forward. Their face should hit the airbag. If it does so, then it is safe for the person. Now on top of this airbag location, if you have kept your pencil box, if you have kept your book, if you have kept your purse, you have kept some some liquid that is sitting there, whatever is there, you kept your tiffin box there, then it is not the airbag that hits your face, it is the tiffin box that will hit your face, it is that geometry box that will hit your face, and so on. So they don't want you to keep anything here, they don't want you to keep anything there. So how to prevent you? So, but behavior is that, right? You get into the vehicle, you just sit, you have some few assorted things in your hand, you just put it on top, the way you would put it on a table, right? You come home, you put something, or you put your key on the house key on the table, you may have your wallet, you put it on the table. So these kinds of things you do, this is your natural behavior. So now, but I understand as a designer that your natural behavior is going to be dangerous for you in this case, because this I don't want this airbag to push those things to your face. I want you to keep that place clean. How do I make sure that you keep it clean? If I just write right here, don't keep anything here, don't keep items here, most people will ignore this, right? They will see it, maybe the first time they see it and then they do something, but most of the time just by habit they'll keep something there. So putting a sign here, even though it is very logical, right, it's very logical, will not serve the purpose. On the other hand, if you make this surface curved, then naturally anything you keep there will slide down, right? So you get into the car, you first keep it there, it will start sliding down. So then you realize that you cannot keep it there, anything you keep there falls off. So now you find some other place to keep. So you have you have this storage area here, and maybe there are other storage areas in the vehicle. You push your bag there, you don't keep it on top, you don't keep your box on top, you don't keep your tiffin box on top, nothing, right? Your lunch box, nothing you keep on top of this surface, because you are forced not to keep it there. So this is a design which takes your human behavior into account. It says that, look, you should not keep something here, I have made it such that you will not keep it there. You try, you will fail, and then you will understand, I don't have to come there and tell you don't keep it there, don't keep it there, you will automatically keep it somewhere else. So this is a nice way of taking that into account. There's another reason also that they would like to keep this curve, and another reason why you don't want items there is, supposing you keep a sheet of paper here, which is what is done here, then what happens is, because the windshield is here, the reflection of the paper appears there. Okay, so the reflection of the paper appears there. So as a driver, when you see this reflection, it is a glare. You can see here, this is definitely a glare here. This place is, there is a glare due to this reflection of this paper there, which means if there is a pedestrian crossing, or there is some animal that is crossing the road, etc., you will be distracted. You will not be able to see that person, or that some cyclist is coming across, some kid is running across, some some dog or a deer or something is just crossing the road. You will not be able to see it clearly. This will block your vision, right? So generally, for multiple reasons, both for the airbag as well as for this kind of reflections that spoil your view of the road, for all those reasons, they want to make sure that this region is kept empty, and you have not kept any items there. So best thing is to keep the surface curved. Then the more you do that, less chance that somebody will keep something there. So this is a beautiful example of how people have used design to ensure that you don't hurt yourself, right? So that is the basic idea. Okay, I also spoke about cultural aspects, and I told you, there are certain things that we may do in India which not necessary that we will do in other countries, right? So a good example is sitting on the floor and doing some work. In India, we have this tradition that we will sit on the floor, we will cross our legs, we'll sit down and read a book, we'll sit down and read a newspaper, various things we do sitting down. We sit down and eat, we sit down and read newspapers, we sit down and do work on a laptop, lot of things we do sitting on the ground. So normally, so this is what would happen if you are trying to do this at your home. You would sit down, you put your laptop on the floor, and then you're trying to work on the laptop, which basically means your back is bent like this. Okay, so it is bent here. And then if you will sit like that for a long period of time and keep typing something, and so it's just a matter of time before you realize that your lower back is having stress. You will have some stress at the lower back, and then you will find it very uncomfortable. When you get up, you know that you kept your back in an uncomfortable position. Often you won't realize this when you're actually doing the work, because when you're doing the work, you're engrossed in the work and you're kind of in the same position, you don't realize it. At some point, you'll straighten up, and then you'll realize that your back has been sitting in a very uncomfortable position. So it really, your back aches. So now we want to design a product. which allows you to sit in an ergonomically comfortable position while still allowing you to sit on the floor to get your job done, right. So, here is a nice interesting product, which is a chair which sits on the floor. You can see that it is seated right on the floor. It has a nice backrest and it has a cushion for you to sit on. So, this has been taken into account. Some angle, the backrest is at some angle. You have a nice curved table here. Okay, so this is a nice curved table, large surface out here where you can keep your newspaper or book. You can even sit and eat there. You can even keep your food there if you wish. You can usually it is nicer to keep your food on the floor and eat in the traditional Indian setting of putting a leaf on the floor and eating. But if you wanted to, you could use that. And it has additional features. It has wheels with which you can drag this around and so on. So all that thing is taken into account. So if you use this product to sit down on the floor and work, your position would be very different. So here's the position. You can see here, back is quite straight. It is well supported by this backrest. Your arms are in very comfortable position, and your laptop is up here. Laptop or any other device you are working on, very comfortable eye distance you have. So all this is enabled in this device, which takes into account cultural aspects, it takes into account human behavior, it takes into account human needs. Lot of things come together in a product like this, right. So this is a very nice product which addresses all of these requirements. So as I said, this is the position that we would like to avoid. That's the product, and this is the way you would sit. Okay, another aspect associated with cultural aspects of design is these days many things are multinational, right. So you make a product somewhere in say Latin America, and then it is sold in India. You make a product in India, it is sold in Taiwan. You make a product in India, it is sold in Iran, maybe it is sold in Russia, it's sold in UK, various different places it is sold. The product may get sold in different places, produced from different locations. Where is the problem? Why do vehicle companies spend so much time analyzing whether this particular product will work in this particular market? The reason is again cultural reasons. I mean, multiple reasons contribute to it, but cultural reasons are a very important aspect of it. So, for example, if you look at truck companies that have traditionally tried to sell trucks to the commercial market here, generally what happens is in rural settings, because they are traveling over short distances, and it is all in it's kind of a controlled setting, they are not expecting much traffic and so on. Even though it is not advisable, and we normally say this is the wrong way of doing it, and maybe not even the safest way of doing it, culturally you will find, if you go to rural settings, you will find that trucks in Indian settings tend to be overloaded. It is not at all unusual to see a load like this sitting on the truck. Okay, a load which is well above what typically, so it maybe weight wise it is not a lot, maybe it is just hay, so it is just a huge amount of hay, so maybe the tonnage is not a huge amount, but volume wise it is massive, right. So it will be sticking out on all sides of that van. Maybe weight also may be very high, so weight itself may be very high, and so in which case your downward force is very high, and so whatever axle and other things that are there in the vehicle going to the other side and so on, they are all going to be stressed significantly. So any truck manufacturer already puts in a factor of safety. So they will say that this truck can take say 1 ton, 1000 kgs it can carry. Let's say it is supposed to carry 1000 kgs. Okay, so 1000 kgs it is supposed to carry. Now what they will say is that we will design this truck to carry 1500, so 1.5 tons. 1.5 tons I will make it design it to carry 1.5 tons. So I will actually give a factor of safety of 50%. So I will announce that this truck can carry only 1 ton, but I have actually designed this truck to carry 1.5 tons. So that even if people overload it, but I'm not recommending that they overload it. But if they overload it, it will still, the truck will handle. It will still be able to handle. It will not. It is not that when you reach 1.1 ton, it will simply collapse. It will not happen like that. By chance, if you exceed it a little bit, it should be okay. right? Now, the cultural aspect comes if in the sense that you have to actually do a survey of the users in that area to find out how much they overload the truck on a regular basis. Okay, again, like I said, this is not good habit. This is something that you want to avoid, but you have to deal with the reality. The reality may be that people are overloading their truck in significant quantity. So maybe your 1.5 factor of safety of 50 is not good enough. Factor of safety of 50% may not be good enough. You might have to put a factor of safety of 100%. So if you are going to say that the capability of the truck is to carry 1000 kgs, you may have to actually design this truck to carry 2000 kgs. Okay, so only then the truck will actually be able to survive in the market, right? So even as a person trying to sell a product, understanding the cultural aspect of it, the human aspect of it makes a difference in your ability to sell the trucks. Otherwise, what will happen is you will release these trucks, and then after a matter of months, people will say, oh, this particular company truck always breaks down. It is not the fault of the truck. The truck manufacturer has actually done a correct job. They have made the correct truck. They have also given the correct values, saying, no, this is the loading capability of this truck. This is the factor of safety. They have done everything right. But because they did not accommodate for the cultural aspect of how the truck traditionally is getting used in that setting, the truck is failing because it is being pushed to a operating point that it is not designed to operate at. But the from the user perspective, they will not be looking at all these details. They will not look at the technicalities of that the person actually did it right, etc. They will simply say, see, I bought another truck from the other company. I have used it for 20 years. I never had a problem. I bought this, this new truck. They advertised a lot. I purchased it. In 2 months, it broke down. In 2 months, it has not just broke down, it broke down significantly. Now I have to do major repair on this vehicle. So the word will spread. Now this new company is not good. It is not able to, it will not handle our usage. That kind of word will spread. So and then after that, it is very difficult for you to fight it. It is very difficult to come out of this situation as a product if your product has already generated bad name. Okay, so once the product has generated a bad reputation, it is very difficult to fight that and come back and say, no, no, now we have fixed everything. It doesn't work. So you have to ensure that your product always has a good reputation in the market. And for that, you have to be very careful about what is the cultural setting in which you are releasing this product. Okay, so what is this user experience, right? So this user experience is what is this human factor, right? The user experience comes in the human factor. There are various aspects to it, but broadly it is related to two things. A person walks up to a product, okay, so walks up or whatever it is, the person attempts to use the product in some way. Walks up is just a descriptive way of saying it. There's a product on the table or on the chair or wherever it is. The person arrives at the product. Now, first part of that experience is the person should know how to use that product. Okay, so what should he or she do with that product and to make it run? And multiple factors contribute to it, and human factors are very important in that. So we will. So this is usually this is handled by having some user manual. But increasingly, people don't have the time or the patience to look at a user manual. If you bought a product in the 80s, 90s and early 2000s, it will come with a nice thick book. The more sophisticated the product, you'll have a nice thick book. Every feature of the product will be explained, saying, this is the way you do this is the way you do that, and so on. Stepwise, it will be there. There'll be illustration, etc. But most people don't have the time to open that book and look at it stepwise. Okay, so they typically will not have the time to do that. So you have to have on that product some sense of intuitive, features, so that when a person picks it up, and a good example I would say is a camera, an SLR or something like that. When you pick it up, your hand should automatically go to those buttons in the normal way in which you grip the camera. Your hand should automatically go to the buttons which need to be used as you use the camera, right? So many cameras in fact have that. They have a very nice way in which your left hand holds the lens or body of that camera. Your right hand comes like this. This finger is just about where one of the key buttons is, which is the button you need to depress to take the picture. There will be a round dial right near it, which you can shift your finger to. If you move that dial, you can change maybe the timing or the aperture, and your thumb will be behind. your thumb, that will be near a second dial. With that you can change the other parameter. So if this is taking care of the timing, this thumb will take care of the aperture. So very nicely these will all come into position, and it will be set up in such a way that your thumb sits very comfortably, your index finger sits very comfortably. So this is the way in which you will hold it. So how the product should be used? If you have done a good design, taken into factor all the human aspects associated with it, it will be very intuitive. The person will pick it up and will have a very intuitive sense of this is what I have to do. And people feel very happy when you have designed it that way, that I picked it up and it was so easy to use. They will say it's very nice, it's very comfortable to use, very easy to use, right? So this is how it is. So this is something we have to keep in mind, and we'll talk about it in a few other places. The other major thing is what happened during use. This is a very critical thing. Okay, so this is a very critical thing which we sometimes don't realize. We don't give it as much importance as we probably should. What is happening during the use is a very integral part of the user experience. Okay, so for example, feedback is a very important part of making the person understand what happened during use. Okay, so the concept of feedback is very critical. So even in a camera, so when you press something, how do you know that it actually took the picture, right? So you're not very sure when you just press a button. You're not sure what happened, and if there is no feedback saying it took a picture. So many cameras will show you a momentary still. They will show you a momentary still, especially in this day of electronic and digital cameras. It will show you momentarily something will stay still for a fraction of a second, and then it will go away before it becomes live again. So you kind of get some feedback. Yes, something was captured. That moment was captured. That has gone away. Now it is again still showing me whatever is happening. I stop somewhere. I depress the switch again. Instantly, that the moment I press the switch, something seems to freeze for a moment and then it goes away. So I get the impression that yes, some picture was taken, right? So this is the concept of feedback, and it's a feedback example of a feedback that makes me feel comfortable. Okay, so that is good feedback. What is poor feedback? So an example is what you see here, right? Many devices will have one red light like this. They'll have one small red light. So this, for example, is a water purifier. Okay, so this is a water purifier. So I've just taken a close up of a water purifier. It has a red light. Now, for some reason, it has a red light, and it also has a beep sound associated with it. A beep sound and a red light. These two things are available. So when something goes wrong with this purifier, let's say one of the filters is clogged or something like that has happened, or some circuit is not working correctly, this red light will start blinking. It'll start blinking, or that beep sound will start coming. Beep, 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 something will start coming, right? So yes, it is providing feedback. So now normally when it is operating, these things don't happen. So I'm sitting around doing other work, and then suddenly I hear this beep, beep, beep noise. So I walk up there and I see that this light is blinking and there's a beep, beep, beep noise. So some feedback has been given. But this feedback is what we can classify as poor feedback, because this feedback does not tell us what is wrong with that instrument, right? Is it some minor problem with the instrument? Is it a major problem with the instrument? Can I continue using that instrument? How long can I continue using that water purifier? Can I continue using it for the next 1 hour? Can I continue using it for 2 days? Nothing. There is no information that is associated with this beep and associated with this red light. This is useful only for the service engineer. It is not really useful for us. So only the service engineer will know what is going on. In fact, because this product has been designed that the frequency with which this light blinks, the frequency of that beep sound, and how many beeps it makes. It makes 3 beeps in a row, or it makes a continuous beep. So all these things are indicative of specific problems in that water purifier. But a typical user will not know. And some of those problems are relatively easy to handle problems. They may be straightforward problems. You just have to clean a filter, put it back, something like that. Maybe a fairly straightforward thing. But this feedback is not helping me as a user to understand what I need to do with it. So I just come there, I see this thing beeping, I see this light flashing, and I have no feedback. So then what are you forced to do? You continue using it till it suddenly stops. Then you call the service engineer. The person comes and he or she replaces various parts, and then it starts working again. So this is an example where feedback is being given, but it is not very effective. It is very ineffective, in fact, and it's actually quite useless. So this is an example of poor feedback. So again, this is comes to the idea of this thing being logical. Logically, this has been done correct. An engineer has done it correctly. He or she has decided that there are only 5 different things that can go wrong with this instrument. So for the first one, the red light will blink in a certain way. For the second one, it will blink in a different way. The third one, the beep sound will be different. So it is very clear. There's a table which says, it beeps like this, it means that it be so, but the typical user will not know. So this doesn't take into account the user experience, the human factor in this. So this is what I mean by poor feedback. Excessive feedback. What is excessive feedback? Excessive feedback, an example is, there is some emergency, right? So some emergency is there in a particular location, and abruptly a whole bunch of alarms go off. Okay, so a whole bunch of alarms go off and they are not stopping, because see, the alarm was originally designed to alert you that something is wrong. And so naturally they are noisy, they are very, very visible and very evident. So you have this very bright light flashing, or you have this noise that is continuously beeping or something like that. So typically, if you were ever watching a movie, where they're showing you some emergency in a, let's say an emergency in a hospital room, or an emergency in a fire or whatever, what you will find is so many alarms will go off that one of the first things that those people are forced to do, the people who are trying to address the emergency, they are coming there to address the emergency, to maybe assist the patient or assist somebody or something. They are entering that place to assist. They are the emergency service providers. One of the first things they are forced to do is to actually switch off these alarms, because there are just so many of them and they are all beeping and making a whole lot of noise and racket at the same time. And so this is an overload, and it is actually getting in the way of their doing the job. So this is a tricky situation, because you do want the alarms to be prominent and very clear so that it alerts people, but you also want it to happen in such a way that when the people actually respond to it, they are able to do their job without these alarms getting in the way. And again, in this case, there may not be a perfect answer to this. You have to really look at the situation and decide what works, but you have to understand that there is such a thing as overload of the feedback, and then you don't know what to do with it. Okay, so this is the thing. Similarly, there is this idea that you can give error messages. So many times you'll get error messages, but the error message doesn't help because it doesn't tell you what to do, right? So again, error message seems very logical from the engineer's perspective. Something went wrong, I have given you an error message, so I am doing it correctly. There is nothing wrong with what I have done. But from a user perspective, from a human perspective, that as a human being, as I'm using the product, if I get an error message that is not conveying to me what is wrong, it's not conveying to me what I need to do, it's a very useless moment. I see it and I don't know what to do. Classic example is this of an error message that is giving us no meaning for most of us. Many times on your computer you will get this 404 error, right? People who work with computers will know what it is, but most of us will just see this and we have no idea what it means, right? So it simply gives you 404. That may refer to a very specific kind of an error associated with, say, loading something or whatever it is, but that error is not conveying anything to us. So simply putting a number and saying this number error is really a useless way of communicating to a human being what is happening and what you need to do. On the other hand, if you set up the feedback process such that you are helping the person to enable the task, to do the task, that is a very good way of doing things. So modern photocopy machines, for example, seem to do a very good job of it. They have a nice display here, and usually when something goes wrong, this display will change and it will tell you exactly what you need to do. It will say, and it will do it stepwise. So you simply look at the display and you follow the instruction, you can solve the problem. Let's say paper is jammed, the paper got jammed. You have multiple trays, you have a tray here, you have a tray here, you have a tray here, there's another tray somewhere on the other side. So there are multiple trays from which different size papers can come. So there are multiple locations where the paper can get jammed. It is not only one location where it can get jammed. These displays here, this display here for example, will tell you clearly which door to open. It will say, it will point to this door and it will say, give you an arrow like that, and that arrow will be blinking. It will tell you that means this side there is a door which you should open. So it will give you step by step instruction. You open the door. The moment you open the door, this instruction will change. It will give you the next instruction saying that there is one, let's say cartridge there. So it will show you something that looks like a cartridge with a handle, and it will say take this out. So you take that out. When you take that out, then it will show you the paper. It will show you a symbol of a paper saying that that is where the paper is. You will be able to see that there is a paper there. You pull out the paper. Then once you are done, you simply reverse the process. You put the cartridge back, you close the door. It will suddenly, now the display will say all ready. We can continue printing or continue photocopy. So this is a very nice way of providing feedback to a user which helps the person handle the situation. So it helps the person to enable the task, and to continue with the task. Whatever was the task they're doing, they continue doing the task. So we see even within various examples that we commonly encounter, there are ways of giving feedback that are useless. All these are, or there are ways in which it is not really helping us, and there are ways in which it works very well. So clearly, these are examples that we can use to understand what we should do better to have the person using this device have a very good experience. Also, particularly from the context of any software that you write. So now you're working on data science, so you may be writing code for various reasons. You may have a user interface that the person uses to experience this code that you have written, right? So in all these cases, there is a time lag associated with feedback that we have to be alert to, right? So a good example of a physical place where you may have this situation is, let's say you go and press a switch to turn on something, okay? If you don't give any feedback that the instrument actually turned on, the person will think that maybe I didn't press it properly, maybe I need to press it a second time, I didn't press it properly, I have to press it some more, only then it will switch on. So they will press it a second time because they didn't get any feedback that the instrument has started working. But your problem may be that you have designed this instrument such that if you press it once, it will switch on. If you press it twice, it will switch off. You may have set up that that kind of a toggle switch. You press it once, it switches on. You press it twice, it switches off. You press it thrice, it will switch on again. So this person comes, he presses it once, and then doesn't hear anything. There's no light that comes on. There is nothing, no sound coming from the instrument. You've designed a very nice instrument, very quiet, very smooth instrument. There's no noise coming on. Nothing is happening. Today, modern electric vehicles are like that. You switch it on, there'll be absolute silence. You won't even know that the engine is running. Modern vehicles are like that. They're so quiet. So there is no feedback. If you don't see any lights turning on in front of you, nothing is happening, you will have no idea that the vehicle has switched on. So there are many such instruments. You press it, you have no idea that it has switched on. So typical user, what they will do, they will come, they press it once, it didn't work. They'll press it a second time thinking it is going to now switch on. What they have done, they have actually switched it off because you designed the switch like that, right? So this feedback to the person that it is working is very important. How long should it take? So let's say, in fact, you have set up, you have a switch there and there's a small green light there, right? So you have a small green light there, and when you press it once, that green light will switch on, saying that in fact, yes, now this instrument is working. You have an on switch here also, right? So on, it has now become on. But your electronics may be set up such that once you switch it on, 2-3 things have to happen, and then once before the machine actually turns on, gets into the operating position, and then maybe at that point only this on switch comes. Let's say it takes 3 seconds. Now 3 seconds may not seem like much, but actually for a user 3 seconds is a slightly longish period of time. So they sit there 1, 2, 3, and till then nothing has happened, right? And they are all in a rush. So they just come, they press a switch. Oh no, nothing happened. You press it once more. So in that you have pressed it twice within 3 seconds, and so you switched it off. You switch the instrument off, and then you start grumbling, saying, as a user, you grumble, saying, what is happening? This is not working. I bought this brand new. It is not switching on, and so on. So we have to be conscious of the fact that, again, from human factors, there is a certain time lag that users are comfortable with, and so you have to operate within that time lag. So if they are used to less than a second of response time, you have to make sure that this green light comes on within in less than a second. Maybe it's half a second, maybe it is even 0.2 seconds. Ideally, you want it to be in that range, 0.1, 0.2 seconds, so that when you press it on, almost instantaneously that light comes on. Immediately the person knows the instrument has responded. They may think that maybe the plug has not been put correctly, maybe the plug switch has not been turned on, various things may come to their mind. But the moment you press, if you see this green light on, okay, at this base level, this instrument is up and running, right? So you need to understand this time lag. Particularly with software, you are downloading something, right? So you download an app, you install an app, and so on. So you have to set an expectation for the person on what is going to happen with respect to the duration. So in fact, when you download, you often see this arrow. It'll keep on, it'll come down and it'll come down and come down, saying that it is downloading. So that's a good visual feedback to the person that something is downloading. But it also helps to have some idea of the time. Let's say, and people do that in various ways. They tell you what percentage of download. So they will have some marker bar, and So how much ever has downloaded, it'll get filled, and slowly this bar will move forward, move forward, move forward. Like this, it'll keep moving forward as you complete it, and then slowly it moves forward, 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 and then it reaches a full point. Full is done. So this is the progress. So at any given time, you can say, let's say it is only this has been done. So you say 25%. So you know that there's still 75% remaining. You can also percentage helps in some sense, because people get an idea of what is happening. You can also give some expectation of this duration. You can say that it is going to take 1 minute, and you're counting down, and that also people do. Many software installations have that. They will have a countdown timer which will be set at whatever as appropriate based on the speed of the internet, based on various things. It may say whatever 90 seconds, and you will see it count down. Okay. So this is how you address it. You give some feedback of what is going on and how long it is taking, how long it is likely to take to complete the process. And to be conservative, you actually give a number which is little larger than necessary. That is a better way of doing it. If you tell a person that it is going to get done in 1 minute 20 seconds, and they're downloading something and they're watching this clock coming down from 1 minute 20 seconds, the timer coming down 1 minute 20 seconds. If you actually finish it in 90 seconds or 100 seconds, they're very happy. They're very happy that, oh, it got good, it got over. Because in their mind, they have budgeted 1 minute 20 seconds. In their mind, they have budgeted that because they're seeing that on display it says 1 minute 20 seconds. So mind assumes that it is going to be 1 minute 20 seconds. So whether they like it or not, they have given themselves that time. They're sitting there and waiting for this to get over. Suddenly it gets over a little faster, they're very happy. They're very happy. But on the other hand, if you said 90 seconds and then at 90 seconds it's still not done and it's still continuing and continuing and continuing, they get frustrated. People get frustrated because it's kind of a agreement you make with them. It's a kind of, the minute you show a duration, it's kind of an agreement that you've made with them that yes, in this time it will get over. And it is frustrating for the user if you are not keeping the agreement. So you're violating that human angle by exceeding the time. So be conservative, give extra time, and make that person feel happy that it finished faster. They'll be happier with your product. So that is the way you have to think about it in the context, particularly in the context of making different kinds of software and setting up installation processes and so on. There is also this issue of what is the model that we have in our mind of the product. Okay, so I am a user, I use some product. So right now I am not the designer, let's say I am the user. You have given me a product and I am going to use that product. So I am going to bring with me all my life experiences in some sense. Okay, so I have seen things happen in a certain way, I have experienced things in a certain way. So that is the baggage that I bring with me when I try to use your product. Okay, and since we are all living basically in the same world, and let's say your product is mostly oriented towards people in the cities or so on, or people who are all using smartphones, etc., our user experience is actually not that diverse. So we have some limited number of experiences that we have, and most of us have essentially the same kind of the same level of experience, maybe plus minus a little bit here and there, but we come with a baggage of experiences, right? So that makes a model in our mind of what is the product and how it is working, right? And when we interact with the product, this this model that we have in our mind, it's a mental picture of what is going to be happening, is very integral to how we experience the product. This screen that you see here is a typical desktop that you will see, a typical desktop that you will see and experience. So what is our mental picture of this desktop? So this is a desktop of your laptop, let's say. In your laptop, you're seeing this desktop image. So our impression is that there are folders. Okay, so there are folders here. There is different software which you can open and do various things. So when you copy a file and paste a file, etc., in this desktop, you have some mental picture that one file was taken and put inside this folder. Okay, and so when you say save in that folder or push it into that folder, etc., you just drag the icon and push it into that folder, you get that sense that this is what happened. I pushed this file physically into this folder, it is sitting there, right? So this is our experience, this is the baggage that we have. Today, increasingly, much of our experience is not with our desktop, but it is with the cloud. So we are saving our files on the cloud. Okay, so it is I mean, it so happens somewhere out here, wherever you are saving it on the cloud. Okay, figuratively you are saving it in the cloud. But what do the people give us as a interface? They give us an interface which looks exactly like this. It looks like a desktop. So there is a folder here, there is a folder here, and into this folder we are putting a file. So I drag a file, some file I take, I drag some file out here, whatever it is, this word document, I drag it and I put it into this folder. Okay, I have previously taken the same file and I have dragged it and put it into that folder. So this first event happened correctly. I dragged it and pushed it into that folder, it went into that folder, and now I am able to see that it is sitting in that folder. I take the same file and I push it into this other folder here, which is related to the cloud. Now for whatever reason, at that moment, let's say the internet is not working well, my internet connection is down, right? So suddenly this process will not work. I have taken the same icon, I have pushed it into another folder, it is not working. But my mental picture says that this folder is sitting here, just the way this folder is sitting here. That is the picture I have in my mind. This folder is here, that folder is there, and therefore when I drag it and put something into that folder, it should go into that folder. It's right there, right? So by putting a folder here, this icon of a folder on my desktop, you are disconnecting me from the experience that actually it is not on my desktop. It is actually sitting somewhere else. It is in this abstract quantity called the cloud, which is somewhere else. It is some storage which could be anywhere. It could be in Africa, it could be under the sea, it could be in Europe, it could be in Australia, wherever, it could be somewhere in the world. That is actually where this file is going. And so the inability of me to drag it into this icon here, is actually an inability on the part of the system to take this file and put it under the sea in the Atlantic. That is really what we are doing at that moment when I drag it into this folder. But that is not what I am understanding. When I look at this picture, when I look at the desktop, I think it is just, I pushed it into one location of my desktop. So I am wondering why this is not happening. Why is this not happening? Why is it not going in there? So I am struggling with it. So as a typical user, our mental model that we have brought with based on our previous experience confuses us when this is the experience that we have on the same desktop, right? So it is necessary as a designer that if you are setting this up, to somehow give me an indication that this folder here is not exactly the same as this folder here, that there is a difference, that the folder here is on my computer, but this is somewhere on the cloud. And therefore even though I am dragging something here versus dragging something there, there is a chance that the process doesn't happen the same way. And it is not something unusual. It doesn't mean the system is useless or it doesn't work and all those things. It's a momentary problem. There is some problem, it will sort out, and this is the kind of issues that you may face. So this is how we have to address this again, this aspect of the human experience. I would like to close with this idea of human error. So this is a very commonly used term. Anytime something goes wrong, you will hear so many news reports where simply they blame it on human error. They will say, because of human error, this event happened because of human error. That's a very common usage that is done. But if you actually go deeper and try to understand what happened, we find that much of what we are attributing to human error is basically the idea that we are forcing people to perform based on the requirements of the machine, not really accounting for human behavior, not really designing for the human. You force this person to operate under circumstances that don't work, are not reasonable, are not realistic, and then you're blaming that person, saying you didn't do it right, right? And I gave you already this example of this auto drive car. So the car manufacturer can legitimately make the claim that I have set up this system that the car will do everything, the person doesn't have to do anything. So even if it is a 5-hour drive, the person can relax for the entire 5 hours. Only 1 minute when that dog suddenly darts across the road, that 1 minute only this person has to do something. Okay, so if you take whatever 5 into 60, you have 300 minutes of travel. 299 minutes I will take care. You don't bother. I mean, I'm not bothering this person. Only 1 minute I'm expecting this person to do anything. Very reasonable, is very nice for the person. But you have put this thing in a situation that it is not going to work. You cannot expect this person to be just relaxing across 5 hours and suddenly in the 33rd minute intervene. or in the 177th minute intervene. It doesn't, people don't work like that. So you have created a circumstance where you want this extreme alertness abruptly in a moment. After setting them up in, may not be boring environment, maybe very relaxing environments also, boring environments or relaxing environments where you've completely taken their attention off the task and then abruptly expecting the person to do the right thing. So this is a very difficult circumstance to put in and not a fair thing to ask. So many times we do this, even in in plants, the person will sit and watch this whole set of controls. So they'll have a shift, they will come there and there'll be all this display of various things that is happening in the plant. And there'll be various gauges which are on display showing you what is the pressure, what is the temperature, what is the flow rate. Many things will be going on. That is the interface you're given. And you're largely expecting the person to do nothing. You're just expecting the person to look at numbers there, numbers there, numbers there, numbers there, and just sit there. And for hours, this person will sit there just looking at numbers, and you're expecting this person to stay alert. It's a very boring environment to put the human being in. You're almost guaranteeing that this person will not be able to do this task. So after, maybe for 10 minutes, the person will do that. You start seeing the drop in attention that, it happens. And suddenly after 2 hours and 38 minutes, if one gauge goes wrong, that instant you expect that person to respond. It is less likely that the person will be successful at it. Okay, so this is an issue. Boring environments, long hours, people get tired if they are doing the same thing over long hours. Again, that is not dealing with the human aspect very well. As I mentioned, sudden precise action, both in this case as well as in this case, it doesn't really help. Another problem that has come up in a very significant way in modern day world is multitasking. Unfortunately, I would say unfortunately, people have begun to expect multitasking of everybody. Okay, and each of us has a certain range over which we can multitask. Say, maybe a couple of things we can do and so on. But increasingly, the assumption is somehow that yes, you can multitask. I will give you 20 different things to do, and maybe out of that 4 of them you have to do simultaneously, and I still expect that you will do everything right, and I still expect that you will do everything very well. That is usually a very unreasonable ask. Most of the time, if you actually step back and watch things that you did well, you have to give it the time to get it done properly. You have to give it the attention. If I keep on interrupting your attention, you will find it very difficult to do something, right? And at least you will find it difficult to do it well. You may do something, but it will not be your best effort. If I keep on interrupting you, I keep on stopping you, getting in the way, throwing something in the way, you will find it very difficult to do. Whereas if you are able to concentrate and focus, you are usually able to do a better job. So multitasking, I would say, is a little bit overstated, right? So I feel so. It is kind of overstated, and it is likely to cause more difficulties and poorer performance than if you give them time to actually do this. And generally, what you will find is there is a human experience, but many of the rules and regulations in work regions often don't completely acknowledge this, that that this is human thing. There's only certain ways you can do this. Just because you put a rule there doesn't mean the person can actually do it as per the rule. So rules are put using the fact that you have legal requirements. So legal requirements say you put this, you put a disclaimer, you ask this person to sign saying that for the 4 hours he or she will be very alert, then they understand that if anything goes wrong, all these problems will happen. You make the person sign, that's a legal requirement. But it is not addressing a human requirement. A human person cannot perform really at that point, at that kind of multitasking and boring environment and sudden action is a human element. There's a human element there which prevents you from doing that, and often we are not acknowledging that at all, if anything. And finally, you must design such that if there is an error, whatever is the error, the system will settle down in a safe mode. It should not settle down in a destructive mode. So good design does that. Modern design on most products are able to accomplish that. Most modern products are able to accomplish a circumstance where if let's say there is some belt which is driving something, and if the belt breaks, the various parts will quieten down to some state where they are not damaging each other and they will come to a halt. So various things like that. So I think this has been accomplished quite a bit in modern design. But nevertheless, we should be aware that when there is an error, the system should settle down in some safe mode, and therefore the error must result in minimal to no damage. So we had always designed it to enable this. So I will close by saying this, that a design that takes human factors into account is more likely to succeed in the long run. Please remember, you can, if you do a very flashy advertisement campaign, you may be able to get people to become curious about your product, maybe try out your product and so on. But if you want the product to really settle in, you want people to buy it, you want people to recommend it to their friend, to their relative, to their co-workers and so on, you need to provide products and experiences that are very good in the long run, right? So and that happens only if you have taken into account the human factors. If you have set up the experience such that as the person uses it the first day, the first hour, and continues to use it over a week or use it over a couple of weeks, you will find, and the person still enjoys that experience, then says, yes, this is great, it is really helping me in a very nice way, and it is also working very well, it is satisfying my requirement, it is not creating any new problem, and it is very consistent, it is very stable and so on. They feel good about it, then they recommend it to their friends, they recommend it to their relatives and so on. So that is what makes your product really work very well in the long run. So if you've done the initial start well, you will find that the product takes care of itself, right? So that is something that you have to keep in mind. So in many ways, as we saw through this class, human factors are very, very critical, and keeping track of human factors when you design a product is a very important aspect of being a designer. Thank you.